is I can solve a nonlinear system of equations using substitution. We learned how to solve a linear system of equations back in chapter 5. We learned how to solve them by graphing, by substitution, by elimination. So now we're going to solve nonlinear systems of equations, and it says we're going to use the substitution method. We are going to use those graphing calculators to check to see how we did, to verify that our solutions are good solutions. You do not have to do check problems in the homework note, okay? So, review. System of equations is two or more equations working together. In other words, they are not independent of each other. They have to be together, and whatever you say is a solution or solutions, that solution or solutions better make all of the equations in the system true. So when we had a system of linear equations, does anybody remember what the solution looks like on a graph? Linear equations, first of all, linear equations may look like they're lines, right? So if we had two linear equations in our system and we graphed those two lines, what would happen? Where would we determine the solution was? Ricky?
Was it in between or on the sides?
No.
Or on one side of it?
No.
Can you say the question?
So when we graphed two equations that represented linear functions, we got two lines, and we graphed them on the same graph, how could we tell on the graph where the solution was? Where was the solution, Christian?
Were they within the shaded areas?
That was inequalities. We did shading for inequalities. We're just talking about equations. Point? Where they crossed. Their point of intersection. Remember, and it was an ordered pair, wasn't it? We always had to name it as an ordered pair. And then when we learned how to solve them algebraically using the substitution method or the elimination method, we would solve for either the x or the y first, and then we would go back and get the other one, so we would still have an ordered pair answer. So the solution in a nonlinear system is also the point or points of intersection. Where are the graphs intersecting? Oh, if it's a nonlinear system, that means not, let's skip down to here, not all equations are going to be linear. In fact, the ones we're specifically going to work with, one of our equations is going to be linear and the other is going to be quadratic. Well, what kind of a graph do we get for a linear equation, class? Straight line. What do we get for a quadratic equation? Parabola. So we're going to be looking for where does the line intersect with the parabola. Okay? And it can intersect in two spots, 2 points, which would mean there are two real solutions, or it could intersect in just one. Maybe that line's just going to touch that parabola in one spot, or there would be none. In other words, they are never going to touch each other. They're never going to intersect. Those are the three possibilities. So we would either have two ordered pairs for our answer, one ordered pair for our answer, or we would say, you know what? We can't solve this one. There are no real solutions. Ricky?
But I thought parabolas were like just big U's going on and on forever.
Exactly.
So doesn't that mean they could eventually?
Oh, how about we wait and see what happens on the graph?
Oh wait, so if they're like that and then they're parallel to the side of it.
Okay, you know what? How about if we just put this in right now and we see what it looks like? Go ahead. Open your graphing calculator and you get it. Go to y equals. And in y sub 1, if there's anything in your y equals, by the way, we should clear it out. Everybody needs to do this. If there's anything in your y equals screen, clear it out. In y sub 1, we will type in x squared. Remember, use the x key, which is next to the what? Alpha key. And then you use the x squared key to square that. And then subtract 2x, subtract 5. That's what we want in y sub 1. In y sub 2, we're going to put our other equation, the linear one. We're going to put 2x minus 8. And then I want you to do a zoom 6, and it will give you this nice graph. So tell me what's happening.
If it touches
Crossing.
the means crossing like that.
The line is crossing the parabola.
When do you push graph up to?
Zoom 6 we did so that we would get a nice graph.
I can't tell.
How many times is it crossing it?
Two times.
And 2 points, right? Will it ever cross it again?
Maybe.
No. That parabola is going to keep going up this way, and the line's going in a different, and does the line ever stop and turn and go up?
No.
No, it just keeps going in a straight path. So this parabola will only ever be intersected in 2 places by that line. So that means this one, we should be able to, when we solve it algebraically by substitution, we should be able to get 2 solutions, okay? Second column turns it off for a bit. Turn it off, we're going to solve it algebraically, we're going to find out what those solutions are, okay? Solve by substitution. They are both set equal to y. Do you remember the substitution method? You can substitute from one of them into the other. You can replace. So since this one, 2x squared minus 2x minus 5 is equal to y, and 2x minus 8 is equal to y, can't we put this one's expression for y into the other one for y? So,
Or the other way around.
or the other way around, exactly. So we're going to put x squared minus 2x minus 5 equals, in other words, we just replace that y, 2x minus 8. But to solve, do you notice there's a quadratic involved there?
Yeah.
Yeah, what happens when we want to solve a quadratic? It has to be set equal to 0 to solve it. So what should we do to get it set equal to 0?
Equals.
We can't just say equals 0. What are we going to do? Isaiah?
Can we subtract 2 minus 8 equals 9? Or do we like subtract 2x and then add 8?
Yeah, because we have to subtract both of them. And subtracting a negative 8 would be the same as adding 8. So really, we have to subtract 2x to make that go away, right? And we'd have to add 8 to make the 8 move, right?
Mm-hmm.
Do you agree with this? Okay, so now we would come over here and do the same thing. Negative 2x plus 8. In other words, we're getting 0 on the other side. That's our goal. So now we have x squared. What's minus 2x minus 2x? Minus 4x, or negative 4x. What is a negative 5, a minus 5 plus an 8? 3, so plus 3 equals 0. Okay, is this in standard form? Are we ready to identify A, B, and C? Yep. Okay, let's do it. Go ahead. Now, not enough of us did all the parts of 59 in the homework, and one of the questions, the last question, it was, which method did you find the easiest and why? So, did you like the science by graphing? Did you think that was the easiest? The factoring or the quadratic formula? So, Christian, you're the only one who can answer this. Which method did you like the best? Graphing, factoring, or the quadratic formula? The diamond method, which is the what method? Factoring method, yeah. So let's try the factoring method, because it typically, if it is factorable, it sure is a lot easier, isn't it?
Yes.
So our A value is 1. Yes, I love when the A value is 1. That means 3 is going to go up here, negative 4 is going to go down here. What 2 numbers work? 3 and 1.
Negative.
Negative 1 and
Negative 3, negative 3. Negative 3.
I'm not sure how many times I heard it, but that's what it is. So now A is 1. Don't make me work very hard. I'm tired. What's the factored name for this quadratic? What's the factored name for this quadratic? Brooke?
X is x minus 3. And parentheses, and parentheses x minus 1.
There you go. I love it. That was so painless. Okay, now it's been factored. Why did we factor it? Because we're trying to get x. We're trying to solve for x. Okay, so now what we're going to do is use our zero product property, which says set each factor equal to 0 and solve for x. So set each factor equal to 0 and solve for x. Well, at this point, these should almost be no-brainers. What's the first one? X equals 3. And this one?
equals 1.
X equals 1.
And that's.
So are we done?
So,
That has to be
We need points of intersection, right?
Oh, yeah.
We only have the X value of the points of intersection. Harley?
So then do you substitute 3 into the equations? Or into one of the equations?
Into one of the equations, because remember they're working together.
And
So do
then 1 into the other one?
Well, but remember, these guys are working together. They're like, like identical twins almost, even though they don't look alike. They're working together, so does it matter which one we use?
no.
Because whatever happens, it has to make both of them true anyway.
But you
So like, what did you want?
So put 3 in for the x's in these equations.
In both equations?
one.
No, we only have to use one of them. And you know what? We are going to use the easier of the two. Which is the easier of the two?
The linear
The
one.
linear one, the y equals. So we're going to find, I want you to put this, find y. Find y. We need ordered pairs. And we can use either equation. If you would rather use the quadratic equation for one and the linear for the other, feel free to. It doesn't matter. But I'm not gonna. I'm gonna use the linear equation both times because these guys are working together. So we're gonna substitute our x value in for x. This time we're gonna substitute in a 3. And see what our y becomes. I get -2 when x is 3. How about you? Am I right or wrong?
Yep.
Right? Okay. So now I write this as a what?
Ordered pair.
Ordered pair. It's a point of intersection on the graph. What's the ordered pair name for this one?
3, -2.
3, -2. Okay. That's one of those points that you saw on the graph. The other one, y equals 2 times 1 this time, take away 8.
-6.
And this time, yes, we get -6.
1 negative.
Here,
1, -6. Okay, now turn your graphic calculators back on. And if the graph isn't there anymore, just press the graph button. It'll come back. How do you feel? Do you feel like it looks like that's where that line is crossing that parabola? An ordered pair is 3, -2.
Mm-hmm.
And that 1, -6.
Mm-hmm. Yep.
So in other words, if we put this ordered pair into both equations, it would make both of them true. If we put this ordered pair into both equations, it would make both of them true.
Yeah.
Let's go to the table and make sure for sure. Christian?
I did.
I forgot how to get to
Okay,
it.
let's go to second table. That's where we'll see it.
Where's the
Second graph. Second graph takes you to the table. Okay. Well, I want you to find in the table. You should have 3 columns in the table. You have 3 columns.
Yep.
First one is x. Second one is y sub 1. Second one is y sub 2. Go in the table where x is equal to 3. What's true about the y values?
They're the same.
Two.
They're both -2, aren't they? Okay. Go to the table where x is equal to 1. What's true about the y values?
6.
They're both -6. Is there anywhere else in the table that you can find an x value that has this, that the y values are both the same?
No.
Keep searching forever, but it will never be.
It's not even at -1 and -3.
Is there any other place? Can you find another x value that the y values are exactly the same?
Does it go on forever?
It does go on forever.
Oh, really?
Yeah. Okay, but let's not, we wear the battery out by the, don't scroll too far. I mean, do you think there really is going to be any other place? No, because there's only 2 places on the graph where it's crossing, isn't there?
Yeah.
Only 2 points of intersection. And at most, there can only be 2 ordered pair solutions. The other choices are what again?
1 and 0.
1 and none, yeah, 0. None, no solutions at all. Okay, turn it off for right now. Because we're not going to use it until after we solve the next one algebraically. Then we're going to check it with the graphing calculator. Anybody have any questions about this one yet, though, before we move on?
Oh, this one works.
Okay, number 2. They're both set equal to y again. Woo! That makes the substitution thing really easy. So should we substitute just so that this is on the left side, should we substitute like that? Would that be a good choice?
Why not?
So we have x squared plus 2x.
It'll be the same either way. So.
Yeah, it will. It's just that we will, we'll just move things around differently. So the x squared minus 2x, or plus 2x minus 3 is going to go up into the top equation. Start that equation out, and then set it equal to the x minus 5 on the other side. Go ahead and get that one solved for 0. Get 0 on one side. We know how to do it, so you do it, and then we'll go from there. Okay, we have a quadratic, right? By the way, do you agree with my equation? Or do you need to correct me? You agree? You want to correct me, Christian?
I was asking, oh, never mind.
Okay, well, it's quadratic, is it?
Yes.
Factoring method is, you always want to try the factoring method unless you don't like it. If you don't like the factoring method, you go straight to the quadratic formula. But I really want us to try the factoring method. I have to make a point here. I have to. A is
1,
B is
That was
One.
funny.
C is
2.
Did you
okay.
make a point?
Yeah, I know that was a pun, wasn't it? Yeah. Okay, just put me on CNN News. Okay,
One
so
on each side.
What'd she say?
Yeah, we are trying to see it as news. I want to say Carly's news.
okay, we need it to multiply to be 2 and add up to 1.
Oh, wait.
We need it to multiply to be 2 and add up to 1. Ricky?
Negative 1 and 2.
Negative 1 and 2. Negative 1 times 2 is negative 2.
Oh, negative 1 and negative 2.
Negative 1 times negative 2 is positive 2. Negative 1 plus negative 2 is
Oh, never mind. 1 and 1?
No.
1 times 1?
1.
Okay.
Okay,
Well,
well,
is B is
2 and negative 1.
2 and negative 1. 2 times negative 1 is
Negative 2.
negative 2.
ah.
This one is not factorable. Not factorable. But not factorable does not mean not solvable. Not factorable means you better find another method to solve it with, folks. Well, can we use the square root method?
Yes.
Is B 0?
No, maybe not. Quadratic. We have to write all this on.
Quadratic formula. There we go. Oh, that what we learned yesterday. Let's go. Let's do it. We got this. X equals the opposite of our B, which is 1, plus or minus the square root of 1 squared, plus a negative 4 times our A, which is 1, times our C, which is 2. Woo!
Oh, God.
Divided by
All over 2 times 1, right? That was just the substitution step. And now we do X equals, the opposite of 1 is negative 1. 1 squared is 1, plus negative 4 times 1 times 2 is negative 8. You are so on top of it, Blaine. And 2 times 1 is 2.
Wait.
Well,
Go down.
jeepers, did you forget to eat?
Oh, actually, I didn't eat.
Okay, well, then the next step, all we do is we simplify our radicand. We say, what does our radicand become? Riley?
It becomes negative 7.
Negative 7. There is a huge red flag blowing. Riley?
Is a negative and it is not square.
It's a negative and it's not a perfect square. Okay, so what's that tell us? If it's not a perfect square, you have to do what?
You have to.
You end up rounding it, right? Oh, what if it's negative?
You can't get the square root.
You can't take the square root of a negative number. So we're going to circle that part right there. We're going to say, oh my, that's a problem.
But you have to write, oh my, that's a problem.
Yeah. And then we say, no, we just say it to ourselves. No real solution.
So does this?
And that is not, so it's not because it wasn't factorable. That's not the reason there's no real solution. Something cannot be factorable and still be solvable. It can still have solutions. This one just so happened, we just tried the factoring method, and of course, we couldn't factor it because we also couldn't use the quadratic formula for it. Ricky?
And that means like, because,
Nope.
this one we can use for any of them, and since we can't do it here, we can't do it anywhere.
There's nothing else to try. Exactly. Blaine?
I actually have a question. If you do it the other way around, like,
Use the quadratic formula first? Sure, you don't have to try and factor it. Carly?
What's this thing called?
The radical sign.
So if the number in there is negative, then there is no resolution.
That's right, because the radicand, that's the name for that, cannot be negative.
But if the number is, there's no square root to the number, then you just,
So what if it had been positive 7? What if it had been positive 7?
then you do approximate.
Then we would have done what we did yesterday, right? We would have said we have negative 1 plus the square root of 7 all over 2, and negative 1 minus the square root of 7 all over 2, and we would put it into our calculators and we would have rounded to the nearest hundred. But we can't. So I want you to see what that looks like as a graphing calculator. Oh, wait a minute. I want you to predict what that will look like on a graphing calculator. What's gonna happen, Ricky?
I predict that the parabola, the side of the parabola will be parallel with,
Oh, so our problem's gonna be kind of like being lazy and laying down a little bit?
no, I mean like it'll go like this, and then the other line will just go like that on the side, and keep going on without touching.
And what, never touch it?
No.
Oh. So he's saying he thinks the parabola's gonna open up, and the line's gonna go alongside of it somewhere, but never touch it.
Right, because it's gonna be parallel with one side.
Well, parallel to at least some part of it, I don't know if you could, how can you be parallel to, a parabola doesn't have
Or
any
maybe
line.
to the going
Okay,
straight
so put it
across.
in.
just don't.
Try it, y sub 1. Put in your first equation, clear out the one that was in there. And then put in the second equation, clear out the one that was in there before you do. And then graph it, just press the graph key and see what happens. And look at that, like Ricky said, isn't he a good predictor?
Wait.
Everybody see it though.
Wait,
See
what?
it.
Well,
Wait,
wait.
which equation is it?
Yeah,
Just what grade will we start
you're gonna,
using?
you will use that a lot. A lot.
So we don't need this for next year?
Not really.
Can I get one for next year?
You can, but hang on tight to it so it doesn't
There
get
are a
lost.
couple,
because
there are
there's
100 or so.
So.
Okay, what's this bit of, could we just make sure that we understand what's going on here when there are no real solutions, what happens? The graphs what?
They
Never
never touch.
Touch, they never intersect, do they? Okay, so, let me finish this up, close the